Imagine stepping into a machine that can pull you beyond the very edge of time itself. A lone traveler places a trembling hand on a glowing dial marked 10 trillion years, and the humming core awakens. In an instant, the world around him blurs. Earth recedes like a memory. Oceans freeze. Continents crumble. And the sun swells into a red giant before collapsing into a fading ember. Silence follows. An abyss where once there was light. We have left behind not only the story of humanity, we have left behind the very light that once illuminated it. The voice intones, and a question hangs in the darkness. What would you witness if you could truly outlive the stars? We begin with a simple hypothesis, that a traveler, shielded from the ravages of time, could observe the ultimate destiny of the cosmos. In the next few minutes, we will cross three monumental epochs: the era of red dwarf stars, the slow march toward thermal death, and the reign of black holes. And we will ask what each extreme reveals about existence itself. First, however, we must understand why the demise of our own sun is merely the prologue of a far grander tale. Our sun, a modest yellow dwarf, will exhaust the hydrogen in its core in about 5 billion years, expand into a red giant, and eventually shed its outer layers, leaving a white dwarf behind. That white dwarf will cool over countless eons, becoming a cold, dark relic. Yet even as the sun fades, the universe continues to churn. The majority of stars are far smaller than our sun, and their lifespans stretch far beyond the brief fireworks of massive suns. In a few trillion years, the bright main sequence stars that once lit the night sky will have vanished, leaving only the smallest, longest living beacons. Red dwarfs. Red dwarfs are humble, low-mass stars that burn their fuel at a glacial pace. A typical red dwarf can shine for 100 trillion years, some even longer. In the dim twilight of the universe, these tiny suns become the last islands of light. Imagine a world orbiting such a star, its sky perpetually amber, its daylight a slow, steady glow that never truly fades. If life were to persist, it would have to adapt to a perpetual twilight, to a stellar output that changes only imperceptibly over spans that dwarf human imagination. Biochemical cycles would stretch over epochs that we would measure in millennia, while the surrounding cosmos grows ever colder and more empty. Now picture the night sky from that distant world. The Milky Way, once a brilliant river of stars, has long since dissolved into a faint smear of ancient light. Nearby galaxies have merged, their stars consumed or ejected, and the background is a dim afterglow of photons that have traveled for eons. Yet the red dwarf still burns, a solitary lantern in an ocean of darkness. It is a reminder that even in the deepest future, the universe clings to pockets of energy, however modest. What does this tell us about the nature of persistence? The red dwarf epoch challenges our notion that life requires abundance. It suggests that the resilience of existence may hinge on the willingness to endure under the faintest of lights. It also forces us to confront the scale of time itself, where a single human lifetime becomes an infinitesimal whisper against a backdrop measured in trillions of years. If you find this vision of a dim, endless night intriguing, let me know what you think in the comments. How would you imagine consciousness surviving in such a slow, quiet universe? As the red dwarfs continue their patient glow, the universe inches inexorably toward a state of increasing entropy. The next phase will see even these modest suns extinguished, and the cosmos will edge closer to a final, silent darkness. But for now, the red dwarf era stands as a testament to the tenacity of light in a universe that otherwise seeks oblivion. This brings us to the threshold of the next chapter, where the very concept of temperature begins to lose meaning, and the last embers of stellar fire flicker out. The universe, now a tapestry of dim embers, begins its slow surrender to entropy. As the red dwarfs exhaust the last of their hydrogen, their feeble glows dim to a faint whisper, and the cosmic background temperature drifts ever lower, approaching the absolute limit that physics permits. In this epoch, the notion of heat loses its familiar meaning. There is no longer a gradient to drive any process, no sunrise to mark the passage of time. Matter, stripped of its energetic fire, settles into a state of near-perfect uniformity. A cold sea where particles drift without purpose. Imagine a world where even the faintest photon can travel for billions of years without encountering anything else, where the temperature of empty space hovers just above the theoretical floor, and where the only remaining sources of energy are the rarest quantum fluctuations. In such a setting, the very idea of life as we understand it becomes untenable. Chemical reactions would stall, biological cycles would freeze, and consciousness, if it could survive at all, would have to adapt to a reality where change is almost non-existent. The universe, once a bustling arena of creation and destruction, now resembles a vast silent library in which every book has been read and the pages have turned to dust. Yet, even in this profound stillness, the cosmos is not entirely inert. Minute pockets of energy persist, held together by the stubborn grip of gravity. Dark matter clumps. The remnants of ancient galaxies continue to orbit one another, their motions slow but unceasing. Over incomprehensible spans, these structures coalesce into the most massive entities the universe will ever know: black holes. As the last stars flicker out, black holes become the dominant architects of the final chapters, their event horizons swallowing everything that dares approach, even the faint photons that once illuminated distant worlds. Now we step into the era of the black holes, the ultimate custodians of the universe's remaining information. Their masses, ranging from the modest remnants of collapsed stars to the gargantuan behemoths formed by the merger of countless galaxies, dominate the fabric of space-time. In a universe where no new light is born, these dark monoliths are the only sources of measurable phenomena. Hawking radiation, a whisper of particles leaking from the edges of their horizons, becomes the sole beacon of activity. This radiation, however, is vanishingly weak. A black hole the size of a small planet would emit a single photon over a timescale far exceeding the current age of the cosmos. The slow evaporation of black holes marks the final act of cosmic evolution. As each black hole loses mass, it shrinks, its temperature rising imperceptibly until the last remnants finally dissolve into a sea of low-energy particles. This process, predicted by quantum mechanics, ensures that even the deepest wells of gravity cannot hold on to their secrets forever. When the final black hole evaporates, the universe will be left with a thin haze of elementary particles, stretched thin across an ever-expanding void. No structures remain, no forces to bind, no gradients to drive change. It is the ultimate thermal death, a state of perfect equilibrium, where entropy has reached its maximum, and the cosmos is a quiet, featureless expanse. What does this inexorable march toward oblivion tell us about the nature of time and existence? It forces us to confront the humbling reality that all that we cherish, stars, planets, life, consciousness, are fleeting notes in a symphony that continues far beyond the reach of any individual instrument. The scales involved dwarf any human imagination. A single human lifetime becomes a brief flicker against a backdrop measured in trillions upon trillions of years. Yet, within that brief flicker lies the capacity to wonder, to ask questions, and to seek meaning amidst the vast silence. If you have traveled with me through these unimaginable epochs, consider what it means to leave a mark that might outlive the very fabric of reality. Imagine you could send a single message, encoded in the fundamental particles that will persist until the last black hole sighs its final breath. What wisdom, what hope, or what warning would you choose to embed in that timeless capsule? Would you speak of love, of curiosity, of the fragile beauty of a world that once teemed with life? Or perhaps you would counsel future intelligences to cherish the fleeting light, to find purpose even when the universe grows cold and dark. These questions are not merely speculative. They echo the deepest concerns of philosophy and science alike. They ask us to weigh the value of our actions against a backdrop that stretches far beyond our own narratives. As we stand on the precipice of knowledge, looking outward to the stars and inward to the core of our own being, we are reminded that the pursuit of understanding is itself a defiant act against entropy. Each discovery, each insight, each shared story adds a thread to the tapestry of existence, however brief its illumination may be. Now, as the final chapters of the universe draw to a close, I invite you to reflect on your own place within this grand timeline. What legacy will you choose to forge? How will you let your voice resonate, even if only for the span of a single generation? Share your thoughts in the comments below. I am eager to read the visions you hold for humanity's ultimate echo. If this journey through the far future stirred your imagination, consider supporting this channel by liking the video and subscribing, so we can continue to explore the mysteries that lie at the edge of knowledge. Your engagement fuels the quest to bring these distant horizons a little closer to home. Thank you for traveling with me beyond the stars, beyond the light, and into the profound silence that awaits. The universe may be marching toward an inevitable quiet, but our curiosity remains a stubborn flame that refuses to be extinguished. Let us keep it burning, together,